in the unit circle, if we break our circle in half, we'll start with 0 degrees. Before we've gone anywhere, we've gone nowhere. And over here, when we divide 360 by 2, we get 180 degrees. If we divide it in half again, we end up with 4 sections of the circle, each having 90 degrees contained within them. Okay, so now we have 0 degrees, 90 degrees, 180, 270, and then if we come all the way back around, we see that 0 degrees would also be the same thing as 360. Now we can find the exact values for these 4 angles by looking simply at the graph. If we look at the graph of the circle, the specific location of the point at 0 degrees is going to be 1, 0. If we look at 90 degrees on the circle, we're at the coordinate 0, 1. At 180, we're at the coordinate -1, 0. And down at 270, we're at 0, -1. But what if we wanted to find other values? We can divide our 4 quadrants in half yet again, and if we do so, we'll end up with each one having half of the 90 degrees. So each one's going to be an additional 45 degrees. So we would then end up with 45 degrees, 90 degrees, 135 degrees, 180 degrees. They overlap there. And they overlap at 90 and 270. 180, 225, 270, and 315 degrees. Now this is very important because we're going to use these to find the exact values of these coordinates. Now we've talked about the exact values of these being cosine of theta, sine of theta. So each one of these can be found with trigonometry. Looking at my first quadrant, if I come to this 45-degree coordinate and I drop this green line straight down, this makes what we call a reference triangle. It's a right triangle, and it allows us to use our reference angles to find values. So this angle here is going to be 45 degrees. Now, we already know things about 45, 45, 90 right triangles. We know that the 2 sides are going to be congruent. And in this case, we know that our hypotenuse is 1. So we can find out, if we remember our ratio, that 45, 45, 90 is in the ratio of x to x to x square roots of 2. Well, in this case, the side across from our 90-degree angle, our hypotenuse, is equal to 1. So our hypotenuse, our radius of the unit circle, is equal to x times the square root of 2. So if we solve for the length of our sides, x, we end up with 1 over the square root of 2. Now we remember we're not allowed to leave things in with radicals in the denominator, so we have to rationalize this, and when we do so, we end up with the square root of 2 over 2 is equal to the length of one of our sides. So why is this important? This is important because if we look back at our unit circle, now that we know the length of our sides, the exact length, remember we're looking for exact length, this is the square root of 2 over 2, and so is our y value. So that means that at this coordinate up here, this point, we're going to be at square root of 2 over 2 for our x value, our cosine value, and square root of 2 over 2 for our sine value. So now we're going to do the same thing with 135 degrees. Now this one's a little bit different because now our angle is not inside that triangle that we'll draw. So we'll do the same thing we did before. We'll drop a reference perpendicular, make a triangle. And now this is where those reference angles are important. If we do, it's the second quadrant angle, so 180 minus 135, the reference angle that we're going to be looking at is going to be 45. So inside this triangle, it's still going to be a 45 degree. So we have the same idea that we had before. Our cosine of theta is still going to be our x, and our sine of theta is still going to be our y. Well, just like before, our cosine of theta is going to be square root of 2 over 2. But we have to be careful. We're in the second quadrant. What do you already know about x values of the coordinates in quadrant 2? They're negative. So the same thing applies to our coordinates in our unit circle. Take a moment, see if you can figure out, using the reference triangles, the values of the coordinates for 225 degrees and 315 degrees. Hopefully you got the values that I got. Negative square root of 2 over 2, comma negative square root of 2 over 2 for 225 degrees, also was a reference angle of 45 degrees, as well as for 315 degrees, but it would be positive square root of 2 over 2, comma negative square root of 2 over 2, because the x's are positive and the y's are negative. Now take a moment, turn your unit circle paper over so that you have the blank unit circle up, and fill in the angles that we've already worked with. Originally, when we looked at the unit circle, we divided it in half, so let's go ahead and do that again. And this time, instead of dividing each of our halves in half, let's divide them in thirds, so we get 6 equal pieces. Each one of these pieces is going to have a measure of 60 degrees that it maps out. So we've got 1, 2, 3, 4. So we've got those 6 sections, and they're going to be 60 degrees, 120 degrees, 180 is shared, 240, and 300, and again 360 is a shared angle. Now if we do the same thing that we did with our 45, our multiples of 45, and we put that right angle in, that perpendicular line, this time we have a triangle that is a 60-degree triangle that with the angle down at the bottom. Well, this means that this is a 30, 60, 90 triangle, and hopefully we remember our ratios, which means that this would be 30. And the side across from the 30-degree angle is always 1/2 of the hypotenuse. So for us that would be 1/2. And the side across from the 60-degree angle is going to be 1/2, or our side, times the square root of 3, which leaves us with square root of 3 divided by 2. Now, just like before, our x value is our cosine. So the cosine of 60 degrees is 1/2. The sine of 60 degrees is going to be square root of 3 over 2. Now let's take a look at in the second quadrant. No, actually, let's do the third quadrant this time. So if we have this angle that is this pink angle, it goes all the way, so it's 240 degrees. The reference angle this time is still going to be 60 degrees. We put the perpendicular in, and it's going to go back to our closest x-axis, so it's going to go back to the 180 degrees. So 240 minus 180 gives us our reference angle of 60. So that's going to be this angle here. And just like before, we would follow the same pattern. Our side across from that is going to be the square root of 3 over 2. And our side across from the 30 is going to be the 1/2. We have to remember, though, we're in the negatives for both of them. We have negative square root of 3 over 2 for our y's, and negative 1/2 for our x's. So take a moment and fill out the remaining 2 angles in quadrant 2 and quadrant 4. If you have to draw in the reference triangle, by all means go ahead. Welcome back. You check to make sure that your values match mine, and let's go on. We should have one set of dots remaining. So let's divide our circle first in half. And then let's divide each one of our 2 semicircles each into 6 segments. So each one has angles of 30 degrees marked off. So now some of these are going to overlap with ones that we have previously looked at, and that's okay. So take a moment and pause the video and mark all of the angles in. You should have a circle that has 12 sections in it, each one measuring out 30 degrees. So you should have 30, 60, 90, 120, 135, 150, 180, 210, 240, 270, 300, 330, and finally back to 360. Now we can do the same thing with any one of these angles, just like we did with our angles earlier. If we drop the perpendicular in, make a reference triangle, this time it's going to be very similar to our 30, 60, 90 triangles from before, except that they're going to be switched. If you notice, this time the 30-degree angle is going to be across from the sine value, the y value. So that's going to be 1/2. And the x value is going to be the square root of 3 over 2. Take a moment, pause the video, and complete this for 150, 210, and 330. Now that your unit circle is complete, go to the complete blank page and fill in all of the values for the quadrantal angles, the multiples of 30, the multiples of 60, the multiples of 45.